Hey everybody, what's up? I hope everything is fine with you. My name is Robert Wohlfahrt and today let's talk about ls. Yes, I know, if you're working at the Linux command line, then ls is a command you use many times a day. But I bet there are at least one or two command line options for ls you haven't used till today. So let's have a look at the, for me, most useful command line options, and I want to vote at the end of this lesson for my 5 favorites here. Yeah, so let's dive in by sharing my screen. So here we are, and the ls command, you know the ls command, I think, shows you the content of a directory. Yeah, simply call ls and you will see the content of the current directory, or simply call ls followed by the name of a directory and you see the content of this directory. Yeah, so ls gives you simply the content of a directory, lists the content of a directory. The first command line option for ls that will be used most of the time, or many times, is the command line option -a. I bet you already know this a command line option. What can this command line option be used for? -a stands for all. That shows you or gives you everything within the current directory. Yeah? If you call ls just without the -a command line switch, you will get all the files within the current directory, but not the files with names starting with a dot. All the files with names starting with a dot are hidden files, and you only see these hidden files if you call ls with -a for all. Then you see the .bashrc, you see the .profile, -less, hst, and so on. Yeah, these are all hidden files. If you call ls with -a for all, then you see within every single directory these two special directories too. You see the dot directory. The dot directory is always linked to the current directory. Yeah, so if you cd into this directory, if you ls this directory, then you see the current directory. Yeah, dot is always connected or linked to the current directory, and dot is always a link to the parent directory. Yeah, so if you go with cd dot into this directory, or if you list this directory, then you see or you go always to the parent directory of the current directory. Yeah, so within every single directory you have this dot directory and this dot directory. Because their names are starting with a dot, yeah, there are hidden files, or these are hidden files. If you don't want to see every time this dot directory and this dot directory, then use the -a command line switch. -a stands for almost all. So you will see all the hidden files, but not the dot and the dot directory. Yeah, ls-a gives you a clean view of all the files included, or including the hidden files of the current directory or of a different directory. Yeah, ls-a. On many distributions, or I think on most distributions, there is an alias defined, an alias called LA. LA is an alias. This is simply a short form for calling ls-a. So if you have a look at the type of LA, and then you see LA is an alias to ls-a. So as soon as you call LA, and then you see all the hidden files within the current directory. But keep attention, ls or LA is only an alias. And if you need this within a script, for instance, yeah, you want to write a script, you want to automate something, then you cannot rely on aliases. Yeah, so keep this in mind. If you need the output LA gives you, then simply use ls-uppercase A if you need this within a script, within a cron job, for instance. Yeah, okay. There is typically a second alias defined for the ls command, and the second alias defined for the ls command is the alias ll. Let's have a look. Type ll is an alias to ls-alf. The really important command line option here is the command line option -l. ls-l gives you a detailed listing, a long listing of the current directory. And beside all the file names or directory names, you see the meta information stored together with this file. You see the timestamp, you see the size of the file, you see the ownerships, you see the permissions, for instance. And these are all the meta information, and you get them with ls-l. You already know what the -lowercase a stands for all. Then we have an f. F is an interesting command line option if you are working within a terminal without color support. If you call ls, then your ls command is typically defined in a way that you see directories colored in blue, or you see executable files colored in green, you see regular files without any special properties colored in black, and so on. Yeah, and if you don't have these colors, or if you don't see these colors, for instance, then you can add an uppercase F. This uppercase F stands for the classification of the files. And if you call ls-uppercase F, then ls appends at the end of some types of files a special character, and this special character then shows you the type of the file. For instance, if you have a directory, you see a / appended. If you have an executable file, then you see an asterisk appended. If you see, let's have a look at an example. Dave, look, if you see, for instance, a symbolic link, yeah, then you see an @ character appended. Yeah, so ls-uppercase F gives you or appends a special marking character at the end of some file types. Yeah, and ll just combines these two command line options. So if you call ll, the alias ll, then you see every file within the current directory, all the hidden files too. You see the metadata, yeah, just because we have here we have the -l command line option added, and you see some added characters appended to some file names, yeah, to show you the type of the file. Yeah. Okay, so these are some interesting command line options: a lowercase, uppercase, l, uppercase f, for instance. Let's stick with the output of ls-l for a few moments, and let's talk about the timestamp. The timestamp you see here is the modification time of the file. And perhaps you know that every file on a Linux system has 3 different timestamps available. You have the modification time, you have the create time, the change time, sorry, the modification time, the change time, and the access time. And if you want to see a different timestamp within this color, yeah, not the modification time, but you want to see the access time, then simply call ls-l-time equals to a time, then you see the access time of the file, or simply call ls-l-time equals to c time to see the change time of the file. Yeah. Okay, so these are the timestamps. Interesting about the timestamps is that you can format them. You can configure the way the ls command prints this timestamp out. It can be really useful if you start to script later on. Yeah, if you write a script and you wanna process these timestamps, for instance, yeah, then you can, or it can be very handy to format these timestamps. There is a command line option --time -style equals to, and then there are some placeholders, some format words available for printing out an ISO format and so on. If you want to know all these available options, have a look into the manual page of ls. But the most interesting way, I think, of formatting these timestamps is to give a format string. That can contain placeholders. Side note, if you know the command date lets you print out the current date and time, for instance, then you can use a format string with the date command too. You can say how the date shall be printed out. Yeah, and the same format string can be used here. You have, for instance, placeholders for the current year, or for the year as a 4-digit value. Yeah, let's call ls-l in this way, --time style equals to plus %sign uppercase y, the 4-digit year. And let's append an underline together with the current month, or with the month of the timestamp, together followed by an underline with the day, yeah, followed by an underline with the hour, followed by a colon with the minute of the timestamp. And so we have a formatted timestamp as we need it. Yeah. These timestamps are printed out within your current time zone. Yeah. Your system is configured with a time zone. You can set a TZ variable for configuring your current environment, your current shell for using a different time zone. Yeah, and all these timestamps are printed out with your personal time zone or the time zone of the system. If you need the time within UTC, for instance, and you wanna automatically later on process these timestamps, then it can be very handy to use the Unix timestamps for this. Yeah, plus introduces the format string, and then the %sign and the lowercase s prints out the Unix timestamp for every file. These timestamps now are in UTC, and these are the seconds since the 1st January of 1970. Yeah, this is the Unix timestamp. Very, very handy for automations later on. Yeah. Okay, because you can really simply calculate with these type of timestamps. Yeah. Okay, so ls-l prints out timestamps. You can format the timestamps if you want to. You can ask for different timestamps, not only for the modification time, but also for the access time and the change time. And then we have a second property here. This is the size of the file measured in bytes. This is the size of the file measured in bytes. And we have the hello.h file. That is 18 bytes in size. We have the info.pdf with 141 bytes, 141,083 bytes. And then we have demolog with, let's count the characters here, with 1,237,958 bytes in size. And if you have such sizes, it can be, or such values here, it can be very handy to print the sizes out in a human readable format. A human readable format just with units, kilobytes, megabytes, gigabytes, and so on. Yeah? And you can accomplish this via the command line option dash lowercase h. Yeah? Simply append an h to your command line options, and then ls just prints out the units together with the size. This is the human readable format. Yeah. If you have a look at the output here, then you see all the directories. The directory bin, the directory project, the directory tools. All these directories have a size of 4K, 4 kilobytes. That's almost always the case if you see a directory. Yeah? This isn't the size, the sum of all the files, the summary within this directory. Yeah? That's just the size that is needed for storing the metadata of the directory. And this is almost always 4 kilobytes. Yeah? If you want to see what's within the directory, yeah? Not only the size of the metadata, but what's within the directory, then simply use the du command line, command. Yeah? du-sh shows you the sum, the summary of everything, the sum of everything within a directory, and the h again for the human readable format. And then you can see that within bin we have 4K. We don't have any more files within there. Let's have a look. Project has 524K, for instance. Let's have a look at tools, 12K. Yeah. So ls-l or ls-lh shows you every time if you see a directory the 4K, or almost always the 4K. If you want to see what's within the directory, the sum of all the files within the directory, then use the du command line for this. Yeah, but back to the ls command. Let's sort the output. If you have a look at the ls command, then you see the output is sorted by default by the name of the file. First, the bin, demolog, hello.sh, and so on. And if you want to sort by a different property, let's say you want to sort by size, then simply add a -s command line switch. -uppercase S sorts the output by size. Yeah? You see the largest file is the first file in the output. The smallest file is the last file within the output. Yeah? You can combine these command line switches, and you can add the additional -h command line switch, yeah, for printing out the sizes in a human readable format. Yeah. So now you see the biggest size, the largest size is 1.2 megabytes, a demolog file in the first line of the output, and the smallest file, 0 bytes, as the last file from the output. If you want to see it in the reverse order, let's say you have a really long listing and you want to see the biggest file, the largest file within the current directory, and you don't want to scroll back all the way until you see the start of the output, then let's just reverse the output. Yeah, we have two options for reversing the output here. The first is simply appending a lowercase r for reverse. Then you see the demolog, the largest file, as the last file in the output. Yeah, it's the first option. The second option to reverse the output is to pipe, to feed the output of the ls command to a different command, to a second command that simply takes the input and reverses the order of the lines. And this tool is the tool tag. Yeah, so if you have if you have a command and this command gives you lines and you want to reverse these lines, then you can simply pipe via a vertical bar the output, the data stream, to the tag command, and then you have the reverse order within the output. Yeah? But if we stick with the ls command, ls-l uppercase SHR, yeah, that's the same. Okay, dash uppercase S lets you sort by size. If I look into a directory, for instance, I have a look into the directory var_log because I'm searching for a log file. I want to debug a service, for instance, then I'm interested in the timestamps of the files. I want to see the files sorted by their timestamp. You can, or I can accomplish this with the -t command line switch. Yeah, order of all the command line options doesn't matter. You can combine them. -lt. Now I have sorted the output of ls by the timestamp, and typically, if I want to sort by timestamp, then I want to see the newest files at the within the last lines of the output. So I want to reverse this output to ls-ltr is the combination of command line switches I use really often to see at the first glance what are the files modified within the last hours, minutes, days, whatever. Yeah. So with my log files, if I want to debug a service and I'm searching for error messages from the last hours, let's say, then I know that I only need to look through these files, yeah, just because all the others are from different days. Yeah, ls-ltr. Okay, so these are some really useful command line options. Let's take the last one, I think, perhaps the last one for today, -r. -r, while -lowercase r stands for reverse, -r stands for recursively. Yeah, please list the current directory recursively. If within the current directory there is a directory, a subdirectory, then I want to see the content of this subdirectory too. And if within this subdirectory there is another subdirectory or multiple subdirectories, then I want to see the content of these subdirectories too, and so on. So I want to list recursively all the files within the current directory. Yeah, so that you see really fast what's going on within the current directory. You can use this, for instance, to search for files. Yeah, if you know that somewhere within the etc directory there is a file called something like passwd, for instance. Yeah, then you can do something like this. Yeah, simply list recursively the etc directory and pipe the output to the grep command, and the grep command then just filters for the lines containing the given pattern here. Yeah, and let's combine this with ls-l, yeah, to print all the passwd files, so that you see we have some passwd files, we have the timestamps, the sizes available, we have a passwd.conf, and so on. Yeah, ls-r is used typically if you are searching for something. If you are searching for something and you want to see recursively what's within a directory, yeah, then use -r. The disadvantage here of searching a file this way is that we don't see the path where this passwd file is located in. Yeah, we have here a passwd file, we have here a passwd file, but these files are within different directories. Yeah. How can we solve this problem? Simply by using a different command for searching. If you're searching for files based on the name, yeah, simply use the find command for this. Yeah. To avoid these permission denied errors here, I call now the find command via sudo, yeah, just because as the normal user Robert, I'm logged in here, I don't have permissions to everything within the etc directory. Yeah. So I call find via sudo, find etc. I say where I want to search for files. I want to search within the etc directory, and now I say I want to search for files based on the name, and I want to see all the files with the name passwd, for instance. And now we see we have 3 files available within 3 different directories, etc pemd, etc cron daily, and etc directly. We have 3 files available with the name passwd. Yeah. Within the last example here, within the grep command, we search, or I search for files with names containing passwd. Yeah, so we find passwd.conf2. So if we want to accomplish the same with the find command, we simply can build a pattern. Simply build a pattern that stands for any character, any number of any character, and then passwd, and then again any number of any character. So we find all the files with names containing passwd somewhere within the name. Yeah, and in this way we see also passwd dash and ch passwd and passwd.conf and so on and so on. Yeah, so for searching within a directory, if you wanna do it really fast and you want to see at a glance what's going on, use ls-r. If you are really searching, yeah, then it is often better or faster or more convenient to use the find command. Yeah. Okay. Now, dash _r wasn't the last option here. The last option here is a different one. We see within the current directory we have 2 PDF files. We have 2 PDF files, info.pdf and info2.pdf. Both with the same size and the same timestamp. So it may be that the second one, info2.pdf, is just a copy of info.pdf. Yeah, and let's change something within info.pdf. Let's change something. Let's change the timestamp. Let's simply change the timestamp. Let's set the timestamp for or of info.pdf to the current time. Let's have a look. ls-l. Info.pdf, the timestamp is set now to the current time. Here it was May the 5th. Now we have May the 27th. But have a look at info2.pdf. What's going on here? Info2.pdf now has the new timestamp, the current timestamp too. What's going on here? Yeah, simply just because both file names point to the same file. Both file names point to the same file. And if we talk about this, you need to know how a file is stored on disk on a Linux system. Yeah. If you store a file on a Linux system, you need 3 things. You need first the data blocks, the content of the file stored somewhere on the disk within data blocks. These data blocks are completely anonymous. Yeah. They don't have a name, they even don't form a file. If they shall form a file, we need a metadata for this file, and this metadata summary or a collection, a metadata collection for this file, and this metadata collection is called an inode. We have an inode. We need data blocks, then we need an inode. An inode contains all the metadata of the file, the timestamps, the ownerships, the permissions, and pointers to this data blocks, but not a name. Yeah, we have data blocks, we have the inode, but we don't have a name yet. We need a name, and the name is now the thing that is within a directory. Info.pdf, this is the name, and the name points to an inode, and the inode points to the data blocks. Yeah, and if you, this is the name, info.pdf, info2.pdf are the names. These names are pointing to inodes. And let's have a look with ls-i. ls-i shows you the inodes. Inodes are numbered. Inodes are numbered. Yeah. So you see only numbers here, and you see info.pdf points to an inode with the number 1452. And info2.pdf points to the same inode. Yeah? So you have two names for the same file, two names pointing to the same file. These are just hard links. Yeah? If you want to, you can create a link to a file. Yeah? Let's create a third link to a file. Yeah? Let's call ln. I want to create a link pointing to info.pdf, and the link shall have the name info3.pdf. Let's have a look. ls-i shows you all these three names point to the same inode, and therefore ls-l, yeah, you see together with all these names the same metadata. And if you open the files and have a look into these files with cat, for instance, or with a PDF reader, whatever, yeah, then you follow the same inode and you will go to the same content. Yeah, so these are three different names here for the same file. Yeah. Okay, so these are a few really interesting and really useful command line options for ls. And let me vote now for my 5 favorites here. So ls-l-a are set. Yeah, then I really often use the -d command line switch to show only the directory entry itself, yeah, and not the content of the directory. Yeah. So if I want to see the metadata of a directory, then I simply use -d. This is a really useful command line switch I use really often. Then I use really often the t, ls-t or ltr together, yeah, to sort the files based on the timestamp. And then I use really often the -h command line switch for the human readable format. So if we count this -h, -tr, 3-d, and from time to time -i, yeah, or if I shall vote for my favorites, then I would stick with -r for recursively. Yeah. So if -l-a are set, just because you use them over and over again, yeah, then my 5 favorites here are the -d, the -h, the -tr, -tr, and the uppercase R command line switch. Yeah. Okay, I hope you enjoyed this lesson. If you want to know more about such tools like these that we talked about today, yeah, then have a look at the Shell Toolbox. The Shell Toolbox is a book I've written by request originally for my clients to give them a reference, to give them an overview over all the tools they need for the daily work. Yeah, every tool within this book comes with a short explanation and with sample calls to illustrate the usage. Yeah. So if you're interested in the Shell Toolbox, go to shelltoolbox.com. Somewhere there should be the link. Hopefully And yeah, I really appreciate taking your time or you taking time for watching this video. See you next time.